All right, so this next section is looking at how these angle pair relationships, how they behave when the two lines that the transversal crosses are parallel. In the last section, we were just looking at any lines that cross. They don't have to be parallel to be able to call them those types of angles. But if the lines are parallel, then there's special relationships, and there's going to be 4 theorems about these relationships. Now, these 4 theorems are all in your valid reasons packet, so you might want to pause this for a second so you can get that out and make sure that you copy these down into your valid reasons packet. So the main thing that you want to remember here is that there's only one oddball. So if you just remember which is the weird one, then you'll be able to remember what the rest of them do. Corresponding angles, alternate interior angles, and alternate exterior angles, so the first 3, if the lines are parallel, then those are always going to be congruent. So those are all the 3 that do the same thing. The oddball is the co-interior angles, and co-interior angles, instead of being congruent, are supplementary. So if you just remember which one is the one that is supplementary, then you can just remember that all the rest of them are congruent instead. So, using those ideas, we are going to solve some problems. And I would come back and reference these frequently as you're working. So, here are a couple of examples. We want to use these theorems to find the missing angle measures. So we want to use the diagram at right to determine the measures of the missing angles. And there's lots of ways that you could do this. But so I look first of all at 120, and the first thing that I think is, well, it's corresponding with 5. So that means 5 is also 120. Then I know that these 2 and these 2 are going to be vertical angles. So that means 4 is 120 and 8 is 120. Now, then I have to look at this next pair here. And you could use any pair. That's the one I'm going to use. Those, since they're a linear pair, have to be supplementary. So that means this one has to be 60 in order to add up to 180. Then 60, angle 3 and angle 2 are vertical, so this is 60 degrees. Angle 2 and angle 7 are alternate interior, so this is 60 degrees. And then 7 and 6 are vertical, so this is also 60 degrees. Now, what I want you to notice is how these end up laying out, because they do the same thing every time. Do you see this zigzag pattern here where they ended up all being the same? That's always going to be the case. Same thing going the other direction. Zigzag here. Those are all the angles that are going to end up matching. So we always want to use as examples of the 4 theorems we've talked about, plus linear pairs, vertical angles. Anything we've done so far is fair game, so you can use those. Now, looking at this next one, this is an algebra problem. It wants us to find the value of x. Now, something that hopefully you notice on this picture is that they've marked these 2 lines as parallel. So since we know they're parallel, that means that those 4 theorems we talked about today are fair game. So if I look at this, 115, this angle here, and the x plus 5 angle, there's no relationship for those. One of them's between the lines and one of them's outside of the lines. So the only one we could hope for would be corresponding, but they're not corresponding. X plus, it would actually be corresponding with this angle right here. So we need to think about how we could figure out the measure of that angle instead. And the fact is that these 2 at the top right here are going to make a linear pair. So if I do 180 minus 115, I get, what, 65 degrees? I think that's right. 70, yeah. And so then, because those are corresponding, I know that they're equal. 65 is going to be equal to x plus 5. And when I subtract 5 from both sides, I get that x is equal to 60. Just a reminder again, those relationships that we've talked about, you only ever have two options. Set them equal to each other or add them together. And the only time you would add them together is if they're co-interior, because those are the ones that are supplementary. All the rest are going to be equal to each other. So that's how you can set those up. Let's look at another one here. These two are, they're both on the outside of the line, so we might want to think about alternate exterior, but the problem is that they don't alternate. So again, we have to try and figure out something else. And so I would use that same idea of a linear pair, and if we subtract here, we get that angle 1 is 44 degrees. So now we know that 7x plus 9, since those are alternate exterior, has to equal 44 degrees. So we subtract 9 from both sides, and then we divide by 7, and we get that x is equal to 5, which is what they asked us for, so we are done. And then the last thing is that this just opened up some new reasons that we can use for some of our proofs. And so here is an example. We're going to spend a lot more time working on the proofs tomorrow, but here's just sort of an introduction. So the first thing that they tell us is that P is parallel to Q, and we're trying to show that angle 1 is congruent to angle 2. Basically, what we are proving is the alternate interior angles theorem. So we can't use that for a reason, since that's what we're trying to prove is true. So the first thing that I would do would be to mark up my picture, which on this one, conveniently, they've already done for us. So these are parallel. I already know that because they told us. Now, that's what was given, was that is parallel. But then remember, I like to go through and mark down what the other things are that I know because of that. It helps me kind of think about where the proof is going to go. I'm not allowed to use alternate interior angles because that's what we're proving. But I do know that I can use corresponding angles. So I know that angle 1 is congruent to angle 3 because they're corresponding. But then I also know something about angle 3 and angle 2. Can you think of what that would be? Those are going to be vertical, so that means that angle 3 and angle 2 are also going to be congruent. And now you can see by the markings that we've done, we can now say that 1 is congruent to 2. So that's where this proof is going to go. So the given is that P is parallel to Q because given. So then angle 1 was congruent to angle 3. We already said that, and the reason for that was because corresponding angles are congruent. That's our reason. And then the next thing we said was that angle 3 was congruent to angle 2, and that is because vertical angles are congruent. And lastly, why is angle 1 congruent to angle 2? Well, if you look here, this is our link. That's a chain, and so this is going to be transitive. Hopefully you're getting good at seeing that one by now. And so that's the end of our proof. So the main thing that I want you guys to focus on today is with the algebra, making sure that you can set up the equations and try to solve. So you need to always ask yourself, do you equal them to each other, or do you add them up to 180? And 3 out of 4 times they're going to be equal to each other. It's that one time with the co-interior that you're going to add them up to 180. So work together, help each other out, and I will be back tomorrow to go over questions with you guys.